Okay, so this one, we're going to spend a couple minutes talking about all these things because it's some pretty deep stuff. Okay, so we're talking about zeros of a polynomial. Okay, so zeros. Zeros is one of these topics that math has a lot of names for. Okay, we also call zeros roots. Okay, we call it an x-intercepts. We call it the solution to your equation, okay, as well as zeros. So all four of these words mean the exact same thing. Okay, so we're figuring out where it crosses the x-axis. Where does it cross the x-axis? Okay, so if we have it in factored form, right? So if we have it in factors where we have linear factors, means we can multiply these things together, then we can look for what we call a multiplicity of the zero. Okay, it's multiplicity. Are there multiple of the same answers? Right? In sports, you're not supposed to be able to repeat a jersey number. So the most people you can have on a team is probably 100, right? 0 to 99, if you can't have three letters, are 100 people, right? So there's no numbers that are being repeated. But we can repeat things in math, okay? And depending on the type of multiplicity, you're going to have a different type of graphical implication. Okay, so let's talk about our graphical implications of multiplicity. So there's three things that we have to be concerned about if our graph has a multiplicity of 1. Okay, as in there's no exponent. So we're looking at multiplicity, we're looking at the power of your factor. So if there's not a number up there, that means it has a multiplicity of 1. And what that means is the graph will cross the x-axis at that point. Okay, so if this is x minus 3, that means our graph crosses the x-axis, right? Normal crossing from positive to negative or from negative to positive. Okay, if we have a multiplicity of 2, okay, like x plus 1 squared. If we have a multiplicity of 2, right, and we know it's a multiplicity of 2 because that's the exponent on your factor, then your graph will bounce on your x-axis. Okay, it won't actually cross, it will bounce. So if it's x plus 1 squared, that means it's going to do something like this at negative 1, right? It bounces. It doesn't actually cross your x-axis. It's the same sign on both sides. And then if we have a multiplicity of 3, okay, like maybe x plus 4 to the third power, okay, we know it's a multiplicity of 3 because of the power on the factor. That's how we know. Then it's going to cross, but it's going to cross at a very basically flat. It's going to flatten as it crosses the x-axis. Okay, so flattens crossing the x-axis, so this would be over here at negative 4. 1, 2, 3, 4. And it would come up like this, and it would flatten. So it would cross, but in a flatter manner than your normal crossing, right? So your normal crossing is going to be fairly vertical. It's going to cross whatever that slope happens to be. This one crosses very flatly, okay, if it has a multiplicity of 3. So any odd multiplicity will always cross your x-axis, and any even multiplicity will always bounce on your x-axis. So if this were a 4, then it would bounce, but much more flatter. So the higher the multiplicity, the flatter it is where the 0 is. Okay, so going back, that was just an aside here. Okay, the multiplicity of a 0 is the blank of its factor. Oh, yeah, exponent. We just talked about that. It's the exponent of its factor. Exponent, or the power, exponent of its factor. Okay, so we're looking up here when we're looking at multiplicities. And if we don't see one, like on that first factor of x plus 4, we don't see a multiplicity, which means it has a multiplicity of 1. Okay, if it doesn't have a power, then that means it has a multiplicity of 1. So let's see, at -4, yes, the graph crosses. The graph crosses at -4. It has a multiplicity of 1. The graph flattens. See how flat this is? The graph flattens when it crosses at -1 because it has a multiplicity of 3. And the graph bounces at +3 because it has a multiplicity of 2. Okay, so our multiplicities have a graphical implication to them. Crossing, flattening, or bouncing. Okay? So let's see, what else do we have? For each of the following polynomials, to determine the degree, find all the real zeros, and state the multiplicity for each one. Okay? So to find the degree, we're going to add all the powers together. Okay? Look at all the x terms and add all of their powers. Okay, the zeros. The zeros are always opposite of your sign. So if you have a positive, if you have a plus as a factor, then that's a -0. Okay, so we're going to set your factors equal to 0 and then solve. Okay, that's how we're going to do it mathematically. Set your factor equal to 0 and solve. And then we're going to look and see, okay, what is the power for each of our zeros? Okay, so we're adding the powers to find the degree. You set each factor equal to 0 to find the 0. And then you are going to see what the power of each factor is. Okay, so let's just jump in here and do this. How many zeros do we have here? Let's just first talk about that. How many zeros? 3 zeros. We have a 0 from this term. We have a 0 from our second term. And we have a 0 from our third term. Hang on, let me go back and make those color-coded. All right, so what is the degree? Let's do that first. The degree is 3 plus 1 plus 2. So this has a degree of 6. Okay, this is an even polynomial. So what we talked about yesterday about the end behaviors, both the left end and the right end will be doing the same thing because all even polynomials have similar end behaviors. Okay, so let's look at our other zeros. Our blue one. What is the 0 from -2x? What if we do -2x cubed equals 0? What does x equal?
Negative or positive?
Well, we're going to divide both sides by
2.
Right, -2. What's 0 divided by -2? 0. 0. Any 0 divided by anything is 0. And then we're going to take the third root. So what's the third root of 0? 0. So our answer is 0. Okay, if we don't have a plus or a minus in your factor, then that answer is 0. Okay, so our 0 has a multiplicity of 3 because it has a 3 on that power of our factor. The multiplicity comes from the power of your factor. So our first root is 0. Right? That's our first one from our first leading term there. And the power of that is 3, so it has a multiplicity of 3. Okay, let's move over to our next one. X plus 1 is our next factor equals 0. So what number plus 1 equals 0?
You do -1.
Minus 1. Okay, and what's the multiplicity for this one? What's the power of this guy's factor?
1.
It's a 1, right? Because there's nothing here, so we're going to call that a 1. It's not a 0 because there's a factor there. If it's missing a power, then the power is 1.
Do we have to write down the x as well?
You have to do what it says. It says find the degree. We did that. And then it says find the zeros. And we said that there are 3 zeros, so we have to find all of the zeros. And our last one is x minus 4. So what number minus 4 equals 0? Positive 4. And what's the multiplicity of that 0? Is 2, because that's the power of our factor. Okay, so we found the degree, we found all the zeros, and we found each zero's multiplicity. Check. We've done all the things. Okay, so let's continue on with our next example.
3x.
Okay, so we're going to do two equations to find the zeros, but what, of course, is the degree? We have an x squared, and we have a fourth power, so 2 plus 4 is 6, another 6th degree polynomial. Okay, so we're going to have two equations. The x squared minus 4 equals 0 is how we're going to find our first roots. And then x minus 2 equals 0 is how we're going to find our second one. Okay, so x squared minus 4. We're going to add 4 to both sides. X squared equals positive 4. And how do I solve a square? Take its square root. Now, how many answers do I get when I take the square root in algebra?
2.
I get 2. Positive 2 and negative 2. Right? So this one factor gives me 2 roots. And what's the multiplicity of each of them?
2.
Each of these have a multiplicity of 1. Each of these have a multiplicity of 1. Okay? The multiplicity comes from your power. Does our factor have a power?
No.
No, it doesn't, right? I can further factor x squared minus 4 to x minus 2 and x plus 2, right? So this one isn't completely factored to as linear factors to begin with. Okay? So both of these have a power of 1. So there's your positive 2 and your negative 2 zeros. Okay? So if it doesn't have a power on your factor, then your zeros have a multiplicity of 1. And what about the purple guy? X equals
2.
positive 2 with a multiplicity of
4.
4. So, let's take a look at this. How many 2's do we actually see?
3.
We see a lot of them, right? This one has a multiplicity of 4, but then there's another 2 right here. So what is our actual multiplicity for our 0? That's a 2.
2. 1.
5. 5. There are 4 here, and there's 1 there. 4 plus 1 is 5. So in truth, right, this is a kind of a strange one. The 0 of 2 has a multiplicity of 5. Arg, x equals 2 has a multiplicity of 5. But then what about our other 0 of negative 2?
It's 1.
How many negative 2's are there?
1.
Just 1. Okay? So yes, if you wrote 4 as a multiplicity and then 1 over there, that would be correct also. But in actuality, there are 4 zeros, right? Because this has a multiplicity of 4. But then there's another 2 here, disguised. So there are actually 5 zeros that have x equals 2 as their roots. Okay, so it's going to cross very flatly at positive 2, and it's going to cross normally at negative 2 for our graph. Okay, yeah, it's kind of tricky sometimes, huh? Okay, what is this one's degree for part C? We have a 3 here, and we have a 5 here. Sorry, a 2. What's 3 plus 5? Sorry, it's 3 plus 2. 5. 5th degree. Okay, we would have to FOIL this guy out if we wanted to multiply everything, right? We'd have to do a whole lot of multiplication.
Hey, why are we not using the other 2 squared?
So the degree is 5, but what about our zeros? Okay, we have to take our first factor, x cubed minus x squared minus 6x, and set it equal to 0. Okay, so factors are things that multiply together. So we have this 3 term times this other 3 term. So x cubed minus x squared minus 6x equals 0. let's factor out an x, right? They all have an x in common. So let's common factor out that x. X squared minus x minus 6. Okay, that's how we would solve this 3-degree or three-term polynomial. The first thing is finding the common factors. And now we turn to our quadratic. What numbers multiply to give us -6 and add to give -1? Okay, because the easiest way to solve a quadratic is by factoring. +2 and -3. Right, so these are the factors. If I did x times x, there's my x squared. 2 times -3, there's my -6. And when I FOIL this, I get a -3x plus 2x gives me -1x. So these are all 3 of my linear factors, right? So I've taken my thing and wrote it as linear factors. They all have a multiplicity of 1. Okay, so my first factor, my first 0, right, my root is from this term. So I have 0. Okay, my second one comes from this term. What number plus 2 equals 0? -2. And my third comes from this term, x plus 3. What number plus 3 equals 0? And that's +3. Okay, so from our left side, we already have 3 zeros. And now we have to tackle the right side equation. Okay, so now we're looking at this one. X squared minus 7x plus 12 equals 0. I told you this was intense. Right? Some of these can be very mathematically dense. So this factors to x minus 3 and x minus 4. Right? Those are numbers that multiply to give you +12 and add to give -7. Right? Numbers that multiply to give you 12 and add to give -7. So when I solve both of these, what number plus 3 equals 0? +3. And what number minus 4 equals 0? +4. Okay, so let's list all of our zeros. How many zeros do we have? What are they? There is, let's just go from left to right, left to right. So most negative is -2. And then we have 0, and then we have 3, and then we have 4. Right? So we actually only have 4 zeros, but one of them is repeated twice. And when we have a repeating 0, that means we have a multiplicity. Right? So our 0, our root, our 3 answer has a multiplicity of 2 because it got repeated twice. All these other ones only have a 1. Okay, so we have a -2 with a multiplicity of 1. We have 0 with a multiplicity of 1. We have +3 with a multiplicity of 2. And we have +4 with a multiplicity of 1. Okay, that's what multiplicity means. There are multiples of the same answer. Multiples of the same answer. Okay, so what else do we have left on the front side here? Oh, complexes. Okay, we'll talk about this in the next video.